Rational equations. For the most part of our high school careers, mathematics indeed would always be a subject to remember. Evaluations, square roots, you name them, they're all there. Although typically disliked by many, most of us don't realize the importance of math in everyday life. From the singular variable to the longest chains of equations, all had taken part in shaping the lives we have today. But first, let's talk about one of the more basic things in math we know. Though it is basic, as implied, it serves but as a foundation for the more complex equations we integrate it into. So now we will be talking about rational equations. I ask you, what comes in mind when you hear the phrase rational equations?
Not to be confused with rational inequalities or rational functions, a rational equation differs from the other two due to its incomplexity. Unlike rational inequalities that focuses on inequalities, hence the name, or rational functions that follow a certain frame and where the denominator's polynomial is not equal to zero, a rational equation is something that involves rational expressions. A rational equation has at least one rational expression in a given equation. The variable is typically seen as the denominator. Though there has been no clear proponent of rational equations, the topic has found itself time and time again in the hands of countless mathematicians, which further signifies the importance in mathematics.
Back to the topic at hand, a rational equation may hold at least one fraction as numerator and denominator are polynomials. Let us take a gander at the following to see and identify which is a rational equation. So we have 4 over 2x minus 6 over 4x equals 2 over 10. We also have 10 over 2x minus 6 less than 4 over 2x. We also have the function of x equals 2x squared plus 4x plus 6 over 2x plus 2. Have you guessed it yet? The first set matches the given description as it conforms to the framework of what a rational equation is. That is because 10 over 2x minus 6 is less than 4 over 2x is a rational inequality, and function of x equals 2x squared plus 4x plus 6 over 2x plus 2 is a rational function. You can tell right away by the less than sign that it is an inequality. As for the last one, it fits the description of a rational function based on the structure of the function. Now that we have a subtle grasp on what is a rational equation, why don't we proceed to solving them?
These problems will and may better your understanding on rational equations and hopefully refine your knowledge by assessing your capabilities on the matter. Problem number 1. 7 over 4x minus 3 over x squared equals 1 over 2x squared. To solve 7 over 4x minus 3 over x squared equals 1 over 2x squared, we can apply the cram method, utilized mostly for rational equations. The method is as goes. C. Clear out the fractions by taking the lowest common denominator or LCD and multiplying them to the respective sides of the equation. R. Remove any given grouping symbols. Sometimes solve with the FOIL method that stands for first, outer, inner, and last. If you have any reservations on what the FOIL method is, FOIL is utilized when we multiply two binomials together. For instance, if we had x plus 1 by x plus 2. First, multiply the variables in each binomial with each other, resulting in x squared. Outer. Multiply the outer variable x and the outer number 2, which would give you 2x. Inner. Multiply 1 and the variable of the second binomial, and that will give you 1x or x. Last, multiply 1 and 2. Result is 2. The final result would be x squared plus 2x plus x plus 2, or simplified into x squared plus 3x plus 2. A. Addition of similar or like terms. M. Multiplying and or dividing both sides of the equation by the variable's coefficient. That would leave us with just the variable on one side, the coefficient equating to 1. Now, to apply that to our given problem, we first take the LCD of both sides of the equation so that it has seemed that their LCD is 4x squared, so we can go ahead and jot that down on the sides. Four x times x squared times 7 over 4x minus 3 over x squared equals 1 over 2x squared times 4 times x squared. We begin and enter the cancellation phase. 4x squared times 7 minus 12 over 4x squared equals 2. Then remove groupings. 7x minus 12 equals 2. Then add the similar terms. 7x equals 12 plus 2. 7x equals 14. Finally, we divide both sides by the numerical coefficient on the left side of the equation to complete the process. 7x over 7 equals 14 over 7. X equals 2. Should you internally debate on whether your answer is right or wrong, you can simply substitute the result to x in the equation given. If the statement proves to be true, then your answer is correct. 7 over 4 times 2 minus 3 over 2 squared equals 1 over 2 times 2 squared. 7 over 8 minus 3 over 4 equals 1 over 2 times 4. 7 over 8 minus 3 over 4 equals 1 over 8. 28 minus 24 over 32 equals 1 over 8. 4 over 32 equals 1 over 8. 1 over 8 is equals to 1 over 8. Therefore, it is proven to be true. Not that difficult, is it? Now, on to the next problem.
Problem number 2. 6 over x minus 1 over 4 equals 1 over x. We first get the lowest common denominators, or LCD, from the fractions, which seems to be 4 and x. So we have 4 times x. Next, we multiply and distribute the LCDs. So now we have 4 times x times 6 over x minus 1 over 4 equals 1 over x times 4 times x. From this point, we begin the cancellation phase. So now we have 24 minus x equals 4. Since there isn't anything we can utilize with the FOIL method, we can simply put 24 to the right side of the equation. So now we have negative x equals 4 minus 24. Multiply each side by negative 1. So we have negative 1 minus x equals negative 1 minus 20. Simplify and we have the answer x equals 20, and we're done. Again, should you have doubts about your answers, you can simply substitute 20, which is our final answer, to x.
Problem number 3. 1 over x squared plus 4x plus 1 equals 2 over x squared plus 4x. We take the LCDs first as always. X squared plus 4x times 1 over x squared plus 4x plus 1 equals 2 over x squared plus 4x times x squared plus 4x. We then distribute the LCDs as needed. 1 plus x squared plus 4x equals 2. We then combine similar terms. X squared plus 4x plus 1 minus 2 equals 0. X squared plus 4x minus 1 equals 0. Since we are left with the quadratic equation, we are unable to factor it, and therefore we must integrate our current results with the quadratic formula. Doing so will give us the needed values of x. The quadratic equation is as goes. X equals negative b positive negative square root of b squared minus 4ac over 2a. Now, we begin assigning values as needed. For reference, a quadratic equation is written off as ax squared plus bx plus c. All we need to do, again, is assign rows that conforms with the structure of the All we need to do, again, is assign rows that conforms with the structure of a quadratic equation. So, x squared will be our ax squared, 4x will be our bx, and negative 1 will be our c. X equals negative 4 positive negative square root of 4 squared minus 4 times 1 times negative 1 over 2 times 1. X equals negative 4 positive negative square root of 16 plus 4 over 2. X equals negative 4 positive negative square root of 20 over 2. X equals negative 4 positive negative 2 square root of 5 over 2. Therefore, the values of x are negative 4 plus 2 square root of 5 over 2 and negative 4 minus 2 square root of 5 over 2. We can check to see if these are the correct values by substitution as mentioned beforehand.
So now we have problem number 4. 4 over x squared plus 4x plus 3 equals 2 over x squared plus 4x. So first and foremost, always we take the LCD, then use it to multiply to the respective sides of both equations. So we have the LCD x squared plus 4x times 4 over x squared plus 4x plus 3 equals 2 over x squared plus 4x times x squared plus 4x. So we cancel both sides of the LCD and the denominator since they are the same. We have 4 plus 3x squared plus 12x equals 2. So where did we get 3x squared plus 12x, you may ask? So we got that by distributing x squared plus 4x to the 3. That's why we have that answer. We then remove any groupings and add similar terms. So we have 3x squared plus 12x plus 4 minus 2 equals 0. So we subtract 4 minus 2. We then remove any groupings and add similar terms. So we have 3x squared plus 12x plus 4 minus 2 equals 0. Subtract 4 minus 2, we have 3x squared plus 12x plus 2 equals 0. Since we are left with a non-factorable quadratic equation, we can again use the quadratic formula. So we have x equals negative 12 plus minus square root of 12 squared minus 4 times 3 times 2 over 2 times 3. Then we have now x equals Negative 12 plus minus square root of 144, since that is the answer for 12 squared, minus 24 over 6. Next, we have x equals negative 12 plus minus square root of 120 over 6. Next, we simplify the 120 squared. So we have square root of 120. We have x equals negative 12 plus minus 2 square root of 30 over 6. So we can conclude that the values of x are negative 12 plus 2 square root of 30 over 6 and negative 12 minus 2 square root of 30 over 6.
Problem number 5. X plus 4 over 2x equals 3 over 4. As usual, we find the LCD first. Then we multiply them to both sides. 4x times x plus 4 over 2x equals 3 over 4 times 4x. 2 times x plus 4 equals 3x. Remove similar groupings by distribution and transposition of numbers. 2x plus 8 equals 3x. 2x minus 3x equals negative 8. Then we add similar terms and finally multiply each side by negative 1 to conclude and get our results. Negative x equals negative 8. Negative 1 times negative 8 equals negative 1 times negative 8. X equals 8.
If you've been wondering why solving rational equations has been fairly easy, that's because it is. It is, after all, merely a part of something bigger and greater when it comes to mathematics. So as long as you have enough math sense and enough care to make sure you aren't misplacing any values, solving rational equations is guaranteed to be simple. Just remember the following points. Make use of the cram method when solving rational equations. Utilizing it will ensure quick solving. Take note of the FOIL method when it comes to the removal phase of the cram method. Next, take note of using the quadratic formula when you encounter a quadratic equation whilst solving. And lastly, substitute your final results to the variable of x in an equation should you doubt your answers.
And that concludes our topic for today.
This has been Janine Salvado.
And this has been Lian Yesenia,
your presenters
for Group 3
11 Hope.